So we're doing probability section 11A from the probability chapter 2 packet. And in this one, if we had a pair of dice and we rolled the dice and we add the numbers on the top, for instance, I have a set of dice here and we have a 5 on the one die and a 2 on the other, and we add those together, we want to just list the possible outcomes we get when we roll 2 dice. So we're not actually going to roll them over and over again, but just think of the different numbers on the 2 sets of dice. Each die has a 1 through 6 and 2 separate dice. So the top row here represents one of the die and the side row here represents the other die. So if we rolled a 1 and a 1, the sum of the 2 die would add up to 2. And then if we rolled a 2 on the one and a 1 on the other, the sum would be 3. So we're just, again, keeping track of the total amount if we add the die together from each die. And then a 3 and a 1 gives us 4, and a 4 and a 1 gives us 5, and so on. 5 and 1, 6, 6 and 1, 7. And then again, if we just continue, the 2 and the 1 together give us a 3, and then a 4, and these are just the sums. 5, 6, 7, 8, and then a 3 and a 1, 3 and a 2, 3 and a 3, so on. So it's pretty easy to fill out the table. It's basically an addition chart. 5, 6, 7, 8, 9, 10. The 6 and the 4 give me the 10. And 5 and 1 is 6, 7, 8, 9, 10, 11. And then 6 and 1 is 7, 8, 9, 10, 11, 12. So what I basically have now is a chart of all the possible outcomes when I roll 2 die. I could roll die, and that would be one of my outcomes, a 6 and a 2. And there's actually more than one way to get that. I can get an 8 this way with a 6 and a 2, or I get an 8 this way with a 6 and a 2. So there's oftentimes more than one way because there's 2 different die. There's this way to get a 6 and a 2, or there's this way to get a 6 and a 2. So you actually have 2 different ways with 2 dice, this way and this one. But there are other ways actually to get 8s. So there's all these different ways to get 8s. Some of them are the same and some of them are different from each other. And so now what we want to look at is that the probability of rolling each particular combination. So down here at the bottom we have the probability of if you rolled 2 dice of 2, and of course there's only one way to do that, and if you look at all the possible outcomes, there's actually 36 possible outcomes. 1, 2, 3, 4, 5, 6 times 6 is 36, and there's only one way to get basically snake eyes, 1 and a 1. There's only one way to do that with a pair of dice. 1 out of 36 is the probability of rolling that combination, which is right there. Well, how about the probability of rolling a 3, combination of 3? Again, we just look at our chart, and it looks like there's 2 ways out of 36, and that reduces to 1 out of 18. So we always want to reduce our fractions whenever we can. So 1 in 18 chance of a 3, and if we continue to do our probabilities, the probabilities of rolling 4s, there's 3 ways to do that with a pair of dice out of 36. And again, that fraction will reduce. 3 goes into itself once and into 36 12 times, so 1 in 12. And so you can see that our probabilities are actually increasing. There's more ways to get these than there was to get the first one. And so the number on the bottom of the fraction is actually getting smaller because there's a greater chance of getting these other combinations. So if we move on to the 5, probability of getting 5 now, you can see it's that whole set there, which is 4 out of 36. And again, that reduces to 1 in 9 because 4 goes into 36 9 times, so 1 in 9. And then the probability of 6s, there's lots of those. So we're getting lots and lots more. All of those ways. 1, 2, 3, 4, 5 out of 36. And this is one of those fractions that we can't reduce because 5 is prime and it doesn't go into 36, so that's the best you can do for 6s. And then 7s. 1, 2, 3, 4, 5, 6 out of 36. So we have 6 out of 36, and that is reduced to 1 every 6 rolls. And that's why sometimes they say lucky 7s, is because on a pair of dice, the most common thing you can get, or at least the easiest roll to make, is a 7, because there's 6 ways to do that with 2 dice. And then if we go on to 8s, you can see that now the number's going to reduce. 7s was the most, and now 8s is going to be the same as 6s, or 5 out of 36, and that doesn't reduce. And then 9s, there's 4 of those out of 36, which reduces to 1/9, just like it did over here with the 5s. So the 5s and the 9s have the same probability as each other. And then the 10s, 3 out of 36, which again reduces to 1 in 12. And then the 11s, 2 ways to do that. Out of 36, or 1 out of 18. And of course the last combination, 2 6s. And again, if you think about a pair of dice, just like 2 1s, there's only one way to do that. That's it. 1 out of 36 possible rolls. That's why it's a hard one to do, to get double 6s or snake eyes. Those are the 2 most difficult rolls to make on a set of dice. And that's how we find the probabilities for a standard set or a pair of dice.